Hello guys, welcome to our channel. In this video we are going to see about the short notes for quick revision in the chapter of physics. First chapter, the electric charges and fields. So let's start going. First one electrostatic unit, 1 ESU is 1 by 3 into 10 power 9 coulombs, and 1 electromagnetic unit means 1 EMU is 10 coulombs. Then permittivity epsilon naught, its value is 8.85 into 10 power minus 12 coulomb square Newton inverse meter power minus 2. Then relative permittivity is equal to epsilon divided by epsilon naught equal to K, which is the dielectric constant. We can also write this equation as epsilon equal to K times of epsilon naught, where epsilon naught is the permittivity in air, free space. Then force. If the force is expressed as positive, means it is repulsion. If it is represented in negative, means it's an attractive force. Then null point. You take this arrangement. Q1 and Q2 are arranged likewise. Then there are two conditions. Means if both the charges are like charges, means x equal to r, which is the distance between two charges. R is the distance between the two charges, divided by root of q2 by q1 plus 1, and the null point will lie in the center of the two charges, in between the two charges. Then if unlike means, if the charges are unlike, means one is positive and other is negative, then it will become x equal to r divided by root of q2 by q1 minus 1, and the null point will lie at the terminal position and towards the weak charge. If this is plus 3 and this is minus 2, means 2 is the weak charge, so the null point will lie here. In this region the null point will lie. Then electric field, E equal to F divided by Q naught, which is equal to force equal to electric field into Q naught. And the electric field, this is the formula for electric field, E equal to KQ1 divided by R square, which is the distance between the two charges, and E is independent on source and also the test charge. This is the source charge and Q naught is the test charge. It depends on the distance, only on the distance between the two charges, means E is inversely proportional to R square here. Then charge induced due to induction. If an uncharged body is induced with the help of a charged body, means the charge induced in the uncharged body will be equal to the negative of, means if you are charging the uncharged body with a positive charge, means the uncharged body will get negative charge. So here it is negative q minus q divided by k. This is the charge present in the charged body, and this is the q dash is the charge induced in the neutral body. Here k is the dielectric constant. Next one, if q1 charges q1 are arranged likewise, in between which q2 is placed, and hence the system gets in equilibrium. Due to this arrangement the system is in equilibrium. Then what is q? What is q to make the system equilibrium, they are asking. Here you take the force in q1, net force in q1 is equal to 0. You apply for both the forces, means q1 and this q1 and q2 and q1. What is the force between them? Both are equal, and you equate them, means q2 will be equal to minus of q1 x by r the whole square. Then simple pendulum, consider it is oscillating likewise. The force due to gravity is mg, and the tension acting in the wire is resolved into two components like T cos theta and T sin theta. What is the force? Means mg tan theta. Mg tan theta is the force, and the charge of the body is, if it is charged, both the bodies are charged, it is It is going towards the ends due to repulsion. What is the charge in this? Means it is equal to r root of mg tan theta into 4 pi epsilon naught, where q means r equal to 2l sin theta. You apply for here and you will get for q. If the total system is placed in a medium of dielectric constant K, of liquid of density rho L, and solid density is rho S, what is the dielectric constant, they will ask. Here T cos theta will be equal to the apparent weight, which is equal to mg minus mg rho L by rho S. If you solve this, you will get mg into rho S minus rho L divided by rho S. You apply for force and the K value you will get, which is equal to rho S divided by rho S minus rho L. If a charged body which is suspended freely is acted upon by electric field, and for different types of electric field, what is the time period? They will ask for you. First, the electric field is in the direction towards upwards. So the acceleration, always know this, acceleration equal to EQ divided by m. The effective acceleration due to gravity becomes g minus a, means g minus EQ by m. So time period equal to 2 pi root of L by g normally. It will become g minus EQ by m. And if it acts downwards, means t equal to 2 pi root of L by g plus EQ by m. So the effective acceleration due to gravity gets added up with a acceleration. Then if it is horizontal direction, if it is in horizontal direction, means the effective acceleration due to gravity becomes root of g square plus a square. A square is EQ by m the whole square. So time period will become 2 pi root of L by root of g square plus EQ by m the whole square. If electric field is 0, normally the time period is 2 pi root of L by g. Then what is the strength of the charge? Means it is dependent on the number of electric field lines going out or coming from a charge. That is called the strength of a charge. Let us take this example, which is Q1 and Q2. See here, for Q1 the strength is different, Q2 the strength is different. Why its strength is different means it depends on the field lines, number of field lines. So from Q1, 1, 2, 3, 4, 5, 6, 6 electric field lines are coming out, and going out or coming from. How much it is coming from? For Q2 means 1, 2, 3, 4, only 4. So their ratio becomes 3 by 2. So which has more strength means Q1 has more strength, which is 6. Then it is also represented as the number of electric field lines passing through unit area, and it also gives us the strength of electric field. Consider this one. This is the unit area, and the number of field lines decides the strength of the electric field. Always electric field is perpendicular to the charged surface of the body, charged body surface, and the electric field lines contract longitudinally and expands laterally. Expands laterally. Then linear charge density means charge per unit length. Sigma, this is the surface charge density, which is Q by area, charge by area. Then rho means volume charge density. It is Q divided by volume, charge divided by volume. Let us take another example. If the electric field lines are horizontal towards the right, if you keep a charged body, the charged body without any initial velocity u equal to 0, just you are keeping, what is the force experienced by it means mass into acceleration. What is the force experienced means this is equal to EQ due to the electric field, which is equal to mass into acceleration. So acceleration becomes EQ by m, which you have already seen. This is the expression for that. Then velocity along the x direction, it will become ux plus ax t. You know a is EQ by m and ux is 0, and vy is also 0. There is no movement in y direction, only the movement is in x direction. So vx becomes EQT by m, where ux is 0. Then the distance travelled means x equal to ut plus half at square, here t. ut plus half at square. It will become always ux is 0 because initial velocity is 0 plus half at square means eq by m, eq by eqt square divided by 2m. This is the distance traveled. Then if it is projected with initial velocity v means what is the cases? Here ax is 0. Acceleration along the x direction is 0. It has only acceleration in y direction as eq by m. You have velocity likewise. Velocity in x direction. This is the velocity in y direction. And this is the resultant of both. Here velocity in the x direction is ux plus axt. Ux, we always know this is equal to v as we are given here. Ax is 0, so the total term becomes 0. Then vy. Vy is uy plus ayt. Uy means what is the initial velocity here? It is 0 along the y direction. We are having only acceleration in the y direction which is eq by m. So vy becomes eqt by m. Now you go for resultant velocity. This is root of vx I cap the whole square plus vy j cap the whole square. You apply for vx and also vy. You will get this equation which is root of v square by eqt by m the whole square. Then distance traveled along the x direction. How much the distance covered in x axis and also in y axis. It is equal to distance equal to speed into time. So the same vx into t. Then y equal to, y is x uy t plus half ay t square. This is the formula. Here uy becomes 0. So we have half ay t square. So apply for this. You will get eq t square divided by 2m. Then tan alpha. What is the alpha value means? This is the deviation angle. This is the straight path which has to be followed, but it has drifted likewise. So what is the angle means? You should divide vy divided by vx. If you go for this, you will get vy divided by vx. What is the alpha means? It is the deviation. So what is the drift? The distance drifted means y equal to eq divided eq by 2m x by v the whole square. You apply for this. You compare both this one and you can get the drift. Here find for t. T equal to x by vx. Apply for t here and you will get this one. Next. P, dipole moment, which is equal to 2a, the length of the dipole, into the charges q. The vector direction of this dipole is from minus q to plus q. What is the axial electric field means? Consider a dipole here, and in this point what is the electric field? This is the axial point. So EA becomes 2 kpr divided by r square minus a square the whole square, and its direction is along the dipole moment of the dipole, along the dipole moment direction. Equatorial. You consider this one as a dipole and it is having the direction of dipole moment towards the left. If you resolve for this, you will get the direction opposite to the dipole moment. Likewise, if it is towards left, it is towards right. So equatorial, this is the equatorial position. So equatorial electric field is equal to minus of, because it is towards the opposite position. So here it should be minus kpr divided by r square plus a square the whole power 3 by 2. For short dipoles means a is equal to 0. A is very small. You take this one as 0 and apply for this. E axial becomes 2 kp by r cube. E equatorial becomes minus kp by r cube. So what is the relation between these two means? E equatorial equal to 2 times of E axial. Then for short dipoles at different distances, r1 and r2, you take this one, and the axial and equatorial electric fields are equal means the relation between r1 and r2 they are asking for. So equate both the thing and you will get r1 divided by r2 equal to 2 power cube root of 2. Then electric field at any point due to a dipole. You take this one as a dipole. At any point you can find around this dipole means what is the electric field? The fundamental formula is Kp by r cube root of 1 plus 3 cos square theta. And this is A. This is the point A. So if you resolve for this point A, along A there is E1, which is in this direction E1. This is E2. This is E2 towards it, downwards and also upwards, both are E2. So if you take for the resultant, it should be likewise. So take for this triangle. Here it is, this is resultant, this is E2, this is E1. So tan alpha is tan theta by 2. How it becomes tan theta by 2 means, see here explanation. E1 is the E axial because it is in the axial line. Axial line, the electric field is present, so it becomes 2 kp cos theta by r cube. Then E2 is the equatorial position. It is in the equatorial position of the dipole, so it is kp sin theta divided by r cube. Because why cos theta sin theta means we have resolved. This is the dipole moment from minus q to plus q. You can resolve likewise p cos theta, p sin theta. Along this one, this is the axial E1. Axial one is present here, and the equatorial. Here it is the equatorial. According to this point as in reference, you see this is the equatorial point, and it is having the dipole moment as p sin theta. So cos theta sin theta have come here for axial and also equatorial. Then tan alpha becomes tan alpha equal to E2 by E1, which is sin theta divided by 2 cos theta, and other terms are common here. So tan alpha becomes tan theta divided by 2. Then torque or moment of couple formula is tau vector equal to p vector cross e vector, or else p e sin theta if you apply for p, which is 2aq dot e sin theta. Then work done to rotate a dipole which is in electric field. If theta 1 is the initial angle between the dipole moment and the electric field, and theta 2 is the final angle between the electric field and also the dipole moment. So work done in rotating them is Pe cos theta 1 minus cos theta 2. Then potential energy means the negative, minus Pe cos theta. This is the potential energy. You have for cos theta is 1. Likewise, what is the potential energy? From the electric field you are rotating, so we should take cos theta 1 as 0 degrees first. Then if theta is 0, if 0 here, you will become potential energy will become minus Pe, which is minimum, and it has stable equilibrium position. Potential energy minimum, stable equilibrium position. Then for 90 degrees means neutral equilibrium position, and it is neither stable nor unstable, it is neutral. Then 180 degree means it has maximum potential energy, which is unstable equilibrium. Then you consider this one. If a dipole is placed with an angle theta with the electric field means, what is the condition? If dipole is disturbed, experiences a restoring torque. If it is disturbed, it experiences a restoring torque, they are saying. Means it is initially along the electric field direction, and I am rotating towards the until the angle becomes theta. So the restoring torque means tau equal to minus Pe sin theta. We know tau is equal to I alpha, and you take for very small angle, then small angle of sin theta will become nearly equal to theta. So I alpha equal to minus Pe theta. So alpha will become minus Pe theta divided by I. So you can have this formula, acceleration equal to minus omega square r. So omega square, if you compare this, you will get omega square equal to Pe divided by I, which is equal to omega equal to root of P by I. Then time period, which is 2 pi by omega, you can get this, and frequency, which is inverse of time period. Always they will ask for you, which is a theory question, oscillation of the dipole. What is the type of oscillation of a dipole? Means it is angular simple harmonic motion. It undergoes angular simple harmonic motion if you place in the electric field. Then electric field due to a ring at point P, along the axis of the ring is EP equal to KQX divided by R square plus X square whole power 3 by 2, and the direction of electric field is along the axis. If electric field is maximum, at which point of the axis the electric field maximum, they will ask likewise. You should what you should do means, electric field maximum means it is constant. So if you differentiate the electric field maximum means you will get 0. So apply for this equation. D and EP, you can take EP value here and you differentiate with respect to x means you will get x equal to plus or minus r by root of r divided by root of 2. Then electric field intensity or electric field strength means it is equal to electric flux density, which is pi. What is the formula means, E vector dot A vector, the scalar product, which is equal to EA cos theta. Then Gauss law. Gauss law means flux is equal to charge enclosed divided by epsilon naught. Okay, which is the charge enclosed in the Gaussian surface. Here, the phi, electric flux density, is independent of size, shape, radius, volume, area, etc. If a charge is placed outside the sphere, what is the flux, total flux they are asking means the influx minus efflux. Influx is phi influx equal to EA cos theta, because area is likewise. This is the area direction and both are opposite direction, which is 180 degree. So EA cos theta becomes cos 180 degree. So we have minus EA, and outwards means you have likewise. This is the area. It is along the direction. So cos theta is 0. Here we will get positive EA only. The total flux, if you add both of these, EA minus EA means total flux will be 0. Then electric field due to a long infinite wire means E equal to 2k lambda by r. Here electric field is directly proportional to linear charge density lambda, and it is inversely proportional to r. Then for infinite sheet, the electric field at a point P, which is at a distance r, is equal to sigma divided by 2 epsilon naught. Here the electric field is directly proportional to sigma only. Then which has different cases. If we arrange likewise two likely charged plane sheets are placed likewise. Okay, we are having now three regions. This is the first region, second region, here third region. Here the first and third region have the electric field as sigma by 2 epsilon naught, because it experiences electric field due to this plate, this infinite sheet by this direction, and due to this infinite sheet along the same direction. If you add both of these, so sigma by 2 epsilon naught plus sigma by 2 epsilon naught becomes sigma by epsilon naught. Here the second region have electric field 0. It has an electric field towards right means this plate, this sheet has electric field towards the left. So both gets cancelled. Now we are having resultant electric field as 0 in the second region. If we have unlikely charged sheets means the electric field at the first and the third region becomes 0. Why means this electric field direction is likewise. Towards left it has right. So 1 and 3 have 0. Both gets cancelled. Here electric field in the second region is sigma by epsilon naught, which is in the same direction. We are adding up sigma by 2 epsilon naught plus sigma by 2 epsilon naught, which gives sigma by epsilon naught. Then electric field due to a spherical shell of surface charge density sigma. If the here this is the shell means electric field outside at the surface, here inside it is the radius of the shell and it is the distances. These are the distances smaller. Okay, first for outside, electric field at outside is kq divided by r square here, which is equal to q. K value is 1 by 4 pi epsilon naught. So apply for this. You will get this one. this equation, and if you multiply the numerator and denominator by r square means you will get this one. So what is surface charge density? This is Q divided by area. Charge per unit area is the surface charge density. So charge divided by area is 4 pi r square for sphere. So if you take this, you can write sigma r square divided by epsilon naught into r square. For the surface electric field is directly it is for r we are having the radius of the shell, which is capital R square. So if you apply for k value 4 pi epsilon naught, you can directly get sigma divided by only epsilon naught. Next, here this outside electric field is inversely proportional to r square here, which is equal to r. It does not depend on that. And for less than r, inside the charge is 0, so the electric field also will be 0. So this region inside it is 0, and for outside r is greater than small r is greater than r. Here it is inversely proportional to r square. So we have rectangular hyperbola. Then electric field due to a sphere of volume charge density rho, and the same cases where the distance is greater than the radius of the sphere. So we are having a sphere likewise. This is the radius, and this is inside, outside it is at the surface. So both are at a distance r. The distance is greater than the radius of the shell, radius of the sphere means E outside will become kq divided by the distance whole square equal to q divided by 4 pi epsilon naught. You apply for k value and the r square. You apply multiply r cube by numerator and denominator. So you will get q by 4 pi r cube. Here also r cube. We know surface volume charge density is charge divided by volume. Volume of a sphere is 4 by 3 pi r cube. So we have pi r cube, 4 pi r cube, which is equal to 3 volume charge density. So here volume charge density, if we are applying for this, we can get this one, r cube divided by epsilon naught r square. So this is the thing. Then r distance is equal to radius of sphere, which is equal to kq by r square. You apply for the k value and multiply numerator and denominator by r. You will get 3 times the volume. Yes, it is 3 times the volume. So q by v, this is equal to rho, r by epsilon naught. Later, if it is r less than r, means inside is kq small r divided by capital R the whole cube equal to kqr. You apply for k value 4 pi epsilon naught and you will get rho r, rho small r divided by 3 epsilon naught. Here for inside, for outside we are having inversely proportional, sorry, for outside we are having directly proportional to r. Sorry, for inside we are having directly proportional to r. For the surface it is directly equal to r. Then outside it is inversely proportional to r square. So for the graph means less than r directly proportional to r, then which is equal to r here, so radius of the sphere. Then after outside means it is inversely proportional to r square, we are having rectangular hyperbola. Then they will ask for electric field due to a sector. This is a rare one. It is better to know this formula. If you resolve likewise, if you are having a diagram likewise, the integral of dE cos phi. So we are having a sector likewise. You take dq amount of charges present in the dl length. Here also dq is present in dl length. You take as a center point of the sector and join this line. This is dE. This is the electric field direction. If you resolve this one, this is phi, which is the angle between the radius radius line and also the dq charge towards the center. Phi means you will get this one is, this is the dE, you will resolve means you will get dE cos theta, dE sin theta, and here also dE cos theta, dE sin theta. And if you integrate the whole thing, you will get the electric field, which is equal to, you know this formula, you could not solve all those things in the exam at within 1 minute. So you better to know this formula. Electric field equal to 2k lambda divided by r sine theta by 2. Then Einstein's relativistic equation you want to know, which is mass equal to mass in motion, which is equal to mass at rest divided by root of 1 minus v square divided by speed of light square. 1 Franklin, which is the smallest unit of charge, that is equal to 3.33565 into 10 power minus 10 coulombs. So this is the 1 Franklin, which is the smallest unit of charge. They can ask a theory question from here. So this is the end of our video. If you like this video, hit the like button, subscribe our channel and share with your friends. Keep watching. Thank you.